All right, we're here at GoToMath.com. Got ahead of myself there. Working using volume or finding volume 5.1, and let's make this. Ooh, how about that one there? That one, that one. That looks like a good one. It says find the volume of the solid form by revolving about the y-axis. So we're going to take this thing, and if you can imagine what this solid looks like, right? It looks like I'd say it the head of a bullet, maybe. If you take this and bring it on around, right? That's what we're going to be finding the volume of, right? So let's go ahead and write this down. F of x is equal to x squared over 15. We're in the interval between 0 and 15, right? Now this interval here, okay, is actually on the x-axis, right? Um, it's probably something that should be said. I mean, if it's written like this, f with respect to x, and this is the x-axis, well, then this would be the interval of the x-axis. So I need to state that because we're revolving about the y-axis. Alright, so we'll sketch this thing up. So this time we're going around the y-axis here, and this is 15. Alright. Now, in order to do this, let me go ahead and write, I guess, we'll go ahead and write up our functions here. Over 15, we're on the interval between 0 and 15. Alright. I'm going to go ahead and write this like this. Y is equal to x squared over 15. Now this is our y-axis, of course, and this is our x-axis. Now we're going to be integrating with respect to y. And that means that what we're going to need to do here is we got to figure out our limits. We're going to be going from 0 up to where? How far are we going to go here? Well, if you take 15 and plug it in, 15 squared divided by 15 is just 15. 15. So volume is equal to, we'll go ahead and write our pi right here. So we're going from 0, so this time we're integrating, this is like a little rectangle here. We're integrating between 0 and 15, alright? Between 0 and 15, and that 15 is coming from here. Alright, it's coming from here. So if I'd have plugged 15 and got 27, you know, we'd have put 27 here or something, right? 27 would have been going here. Now we want to get everything in terms of y. We want to get in terms of y. So that means we're going to take this 15, bring it up over here, and then square root equals x. Do you see that? Okay, it's not too hard, I promise. And then this is our radius. So this represents now the radius. That's the distance between here and here. Okay? And so what we'll do is we just use the same formula. So 15y, and the whole thing is squared. The whole thing is squared. Alright, so we'll go ahead and rewrite this 0 to 15. So when we square root goes away, and that's what we're left with. Alright. You know, there's a ton of other things I could be writing out right now on this whole deal, but you know, let's just try to simplify the matter down as much as we can. You know, you can make it as complicated as you want. 0 to 15. Alright, so we just took the integral of that, added, put 2 down below, and now what we're going to do is go ahead and plug in our limits. So we have pi times 15 times, that's going to be 15 squared over 2 minus, then plug in our lower limit, which happens to be just 0. Now there is something interesting about this I found out, and which is really kind of odd, to say the least, but it seemed like if we were taking this region and revolving it around the x-axis, it turns out I believe the answer is the same. So I'll let you figure that out. All right. Don't hold me to it, but I'm pretty sure it is. Okay, so we end up with 15 raised to the third power divided by 2. And I can't remember if we were rounding on this problem, but I think they want exact value. So we'll write down the exact value. 3375 over 2. We have run out of room to the pi there. Let's scroll up just a little bit. 3375 over 2 pi. Okay, so if everything works out, that's what I got anyway. And it's what the script shows, so I'm pretty sure that's what it is. All right. Anyway, we're at gotomath.com. I think I got one more problem in this section for right now. Check it out and see you later.